Welcome to Metabolic Body Composition. I'm Louis Burns. Today's episode is Oatmeal and the Philosophy of Science. Now, why do you say oatmeal? I watched a discussion debate about oatmeal, and it got me thinking more about what I wanted to say about the philosophy of science, specifically with nutrition in mind. Let me open today with a quote that all models are wrong, but some are useful. That's from George Box. And it guides a lot of my thinking. That itself is a model, so it is wrong but useful here. Science is both a process and the content of that process. The process being the scientific method, where we develop hypotheses after observing the world and then go about testing those hypotheses. And then the content being the results of all those experiments, all those observations. And I was actually chatting with Claude about what settled science means and if it's an appropriate term to use at all. And science, as a process, it's constantly evolving. So there are parts of science that are more well established, have more evidence, have a greater degree of certainty. But as far as being a binary, settled or not settled, that's not as helpful as the concept could be. Another thought issue is called Hume's law. And it's the is-ought problem, which is that we can't get an ought from an is. And what that means is just because there's something we observe in the world doesn't mean that's the way it should be. For example, we have evolution and diet. So just because we can observe hunter-gatherer tribes, our distant ancestors ate a certain way with a certain amount of certainty, whatever we can know about those things, doesn't mean that's exactly what we should eat. It just provides some level of evidence. There's a book on evolution by Henry Gee, and a couple of his insights were that science is primarily about the quantification of uncertainty. That is part of the process, and it becomes part of the content. It's basically figuring out how well or how much we know about certain things and saying how sure we are about them. And then in the book, he goes on to say that evolution is not linear. That's the biggest mistake. The name of the book was The Accidental Species. The idea being that humans were not a foregone conclusion and we're not necessarily the highest level of evolution. One of our species before us may have been better for some criteria. There might be some future species that ends up better than humans. We don't know. It wasn't a line like you usually see in this series of a chimpanzee or something, and then he stands up and then he looks more like Homo erectus and then some of the other species and then humans. It didn't go in a straight line like that, and it doesn't work in a straight line even today. What that tells us about nutrition is that even if we see hunter-gatherers' diets, it doesn't mean their diets are optimal. People will usually eat whatever they can get their hands on. It's just another piece of evidence. Let me segue into an evidence hierarchy. I don't see this discussed often enough. And I think it's good to show here because what I see in social media is either people relying on observational studies or trying to discount the value of observational studies. And I'll just make a list and then I'll make some comments on it. I think the lowest level of evidence is basic reasoning, looking at mechanisms or telling anecdotes, maybe stories people have heard about how the way the world works or how something turned out. Next, I would say peer review narratives or editorials. You'll see these sometimes in journals, and they'll cite evidence, or maybe just their own opinion, but it has been peer reviewed. So it does rise slightly above just one person's reasoning. Above that, we have case studies where a doctor or researcher has seen how something went, how someone's life went, and they were able to document it in a rigorous manner so that we can draw some lessons from it if possible. Above that, I would put observational studies. And I would include anthropology as observation because we can't do randomization. We're not doing any type of controlled trial. We're just making observations. Those studies have some strengths and weaknesses to them we'll come back to. Above that, I would put the Mendelian randomization studies, which are interesting and I'll touch on too. Then if we aggregate some of those, we end up with observational meta-analysis. So those are stronger evidence than the prior ones. Me personally, I would put the next level at N=1 experiments, and almost on a different scale than observational meta-analysis, because if the individual has been trained in scientific methods that control other factors, then for an individual, they are much higher level evidence than meta-analysis. For other people, they sometimes are discounted as anecdotes. If you're finding something about yourself that's personalized medicine or nutrition, that's a higher level of evidence for you personally. Above that, we start to get what people call the gold standard, which is randomized controlled trials, where the randomized means people are not self-selected and they're not cherry-picked. They're spread out evenly and equally and fairly. Controlled trials means we try to control for as many factors so that we're only testing one thing and one outcome. There's more nuance to ways that those can be blinded or double-blinded. Above those are the meta-analysis of randomized controlled trials. So if we are looking into a specific question and we can find a bunch of randomized controlled trials addressing the question, that gives us pretty strong evidence. Now above that, I would put triangulation. And what we mean by that is combining any number of the previous levels of evidence. So if we have randomized controlled trial meta-analysis that is congruent and says the same thing as observational data, case studies, and you're in one experiment, then that's a very strong case, even more than just randomized controlled trials on their own. Observational studies, sometimes the way they get discounted, the strength of them is that they're often very large population sets. Some of the noise falls out. One of their main weaknesses is that all they can do is generate hypothesis. So it's an observation. There was no trial involved. And we can't say there's any type of causation. Although there's a lot of funny business. I see people using causation where nothing could be attributed to causation. Mendelian randomization is interesting. I've seen influencers, researchers use these as bludgeons on people because they have genetics involved. I had my doubts about them because they sounded like another way to stratify. So I went into some of these large language models, Claude and Perplexity, ChatGPT, and asked them to tell me the underlying logic of these studies. Where did the name come from? What are the outcomes? What can we learn from them? What are the strengths and weaknesses of them? And it really confirmed my suspicion. They are also just observational studies. The Mendelian means that they found a genetic marker that they can find correlation with or an association with. Correlation implies a linear relationship. So we just say there's an association, means that there's some relationship there. And it's not completely random. So we find this genetic marker and we look for an outcome we have in mind. They like to say the randomization is because you're born with a certain genome, then it's a natural randomization. I press this on thinking, how is this different than doing an observational study and randomizing that into male and female participants? And the underlying logic is really the same thing, because male-female, it's a genetic phenotype, and it's randomized at birth. You don't know which gender you're going to be until the fetus starts to differentiate, or even earlier if you do genetic testing. But it's just a stratification. It doesn't create a causal factor. It's very pinpointed, and there's a lot of nuance to it, but it's just a stratification. It's a more specific and better detailed observational study. When I see influencers say, because you've got a Mendelian randomization, you have causation. It's not the case. You have better than just a plain observational study, but it's still hypothesis generating. So that's the evidence hierarchy. And I wanted to include that before I went into some of the specifics of nutrition and oatmeal. We'll start with nutrition in general before I talk about oatmeal. I want to go back to the hunter-gatherers. The things that everyone agrees on is that meat was a primary ingredient of our evolution, and that we likely evolved to eat meat. We know that some people, they talk about humans can't be carnivores because we don't have the right teeth, claws, speed, or strength to capture animals. But what we do have is, prior to being Homo sapiens, Homo habilis, the handyman, it was the species that started using tools. So we didn't have to internalize our teeth, claws, and our speed. We had our tools. Homo sapiens are not Homo sapiens without our tools. Our hands are specifically formed to grip spears and knives and tools like that in no way that any other species can. We have early evidence that even before Homo erectus was using fire, found some fish bones almost 1 million years ago. Cooking and tools are part of our food gathering adaptations. So it's not quite correct to say that humans are either omnivores or carnivores. If we differentiate that a little bit, we have facultative carnivores or obligate carnivores. And then we have degrees of carnivory, whether that's meso or hypercarnivore. Hypercarnivore, usually the cutoff is 70% of your calories coming from animal sources. We may be hypercarnivores. That's still up for debate. A facultative carnivore, a species that primarily thrives best on animal products. Obligate carnivores cannot live without animal products or cannot live on anything else. If you feed a cat or a lion vegetables, it will die or get cancer and gingivitis and all these other things, diabetes. It's because we're feeding them processed food the same way we're feeding ourselves processed food. Facultative carnivore means we can derive some nutrition from plant, very limited. Most of the nutrients are not, the plant-derived nutrients are not as bioavailable as animal-derived nutrients. The energy density is not sufficient. Our digestive system handles meat just fine and struggles with plant matter. So it's fairly safe and accurate to classify humans as facultative carnivores, which means we do best on meat. Now, how much meat's up for debate, and the hunter-gatherer evidence, I think, helps us, but that's observational. We can't say that we should be eating it because we see other hunter-gatherers eating it. For example, here the Hutts had mentioned quite a bit, and most of their diet is baboon meat, honey, and some tubers that they chew. But that doesn't mean that every other human should be eating baboon meat and honey as their main calories. It does give us some information about when we look at hunter-gatherers and they don't have the diseases of Western diets, of civilization, so-called, then that's a strong piece of evidence that we should be considering. Furthermore, about facultative carnivores, one of the ways you can test a hypothesis is to ask if there's evidence that the opposite could be true. When we talk about carnivores, sometimes people say, I don't want to go to a ketogenic or carnivore diet because then I want the metabolic flexibility of being able to eat both carbs, fat, and protein. If you switch to fat and protein primarily, your ability to process carbs at a rapid pace may be degraded. I was talking with Claude about it, and it made me think about what metabolic flexibility means and whether the flexibility is in the substrate, carbs versus protein versus fat, mostly carbs versus fat, versus the metabolic flexibility of using fat that you eat versus fat that you store. It seems that, and I don't have a lot of research to back this up, but just I guess there's a known thing among distance runners that they call hitting the wall. And that's when they've done carb loading, eating as many carbs as they can prior to a race. And then those carbs eventually run out. Their glycogen stores are used up and they have to switch to fat burning. And they call that hitting the wall. And I've done it before. It's extremely unpleasant. A lot of conventional distance training has been about extending the period before hitting the wall. The flexibility of switching from carbs to fat is not flexible if you're eating what would be considered a mixed diet in carbohydrates. But if you're fat adapted, you can switch between eating fat for fuel and then switch to using the fat in your body very easily. I've found in my own experience, and this is reflected in the research as well, that doing endurance events while fat adapted, you don't hit the wall because you can easily switch from the fat you already consumed recently and the fat that is on your body. Metabolic flexibility might be something we want to revisit and say, is it better, or is it just to broaden our definition to be flexible between carbs and fat, which is not something that our body does very well, or being flexible between the fat we eat and the fat we store, which gives us consistent energy and allows us to perform long distance and some strength events too. Thinking more about the optimal diet, we've considered the historical context of hunter-gatherers and whether we're facultative carnivores and metabolic flexibility. Let's talk about the present-day factors, because I saw this in part of the oatmeal debate, is how do we weigh the historical evidence versus what we can do in the present. Some of the things that we need to consider about the present is what we know about the nutrition that we require, the essential amino acids, the essential fatty acids, protein requirements, the fact that there is no carbohydrate requirement, there's no fiber requirement. We have a vitamin and a mineral requirement. Factoring all those things, we need to consider the current food supply availability. Even 100 years ago, our fruits and vegetables were not what we have today. We've hybridized them so we can mass produce them. They last longer on the shelf, and they're sweeter. They have less fiber. So that kind of conflicts a little bit with the hunter-gatherer diet approach, because even if we determine the macro ratio they're consuming, we may not have access to the same foods. We don't have access to the exact same foods that our ancestors grew up on or evolved on. That food supply also has to be factored in terms of people live in a food desert or that don't have access to certain types of food. When I traveled in India, it's extremely difficult to get beef, depending on the part of the country you're in. Some places have no meat at all, and others it's widely eaten. In terms of toxins, we know there are natural plant toxins, and some would argue those are at such low levels they are beneficial because they might activate antioxidant activity. We know there's no clear benefit of having gluten, and not just if you don't have gluten intolerance, or oats apparently have the thing avenin that's like gluten. There are oxalates, there are phytates, there are lectins, there are alkaloids. It's not clear. There's a spectrum. People say the toxin makes the poison. It doesn't have to be an acute poison that kills you immediately like cyanide. It's not clear what the long-term impacts are of low-level exposures of these things. There are studies, one of the Mendelian randomization ones I've mentioned, saying that fruits and vegetables are better for you. One of the problems with some of these observational studies is they're comparing without nuance. If you look at the entire population is one health status, but that's not the health status of hunter-gatherers that don't have a lot of the age-related diseases or early onset of type 2 diabetes. The present-day factor is how many of those toxins do you want in your diet? how many can you avoid? And then that's not even counting the man-made toxins like glyphosates, which have been linked to cancer. If you're eating pretty much any amount of plant material, you're also eating glyphosates and heavy metals. There are some reason that some people completely avoid fish that might otherwise be beneficial for a human diet. And we also have to take into account personal food preferences. If you have a food sensitivity or a food allergy, then obviously those are off the table. If you have certain conditions, alpha-gal, that'll make you have an allergic reaction to meat. Maybe some people have histamine intolerance. That means aged meat especially would trigger that, give them an allergic reaction. In our present day factors, we also have the ability to supplement. There's no diet that provides everything that a human can benefit from. A properly structured ketogenic or low carb carnivore diets can supply most of the nutrients that you need. Something like vitamin D, you don't get an appreciable amount from diet. So you either need to be in the sun, appropriate to your latitude and melanin levels, or you need to supplement that. The research I've seen shows that most people are actually deficient in vitamin D because, like our hunter and gatherers populations and ancestors, we're not spending the same amount of time outside or with our skin sufficiently exposed. And then even if some of those diets, I did a carnivore diet for 6 months without any supplementation other than liver, and I had no problems. But I'd been supplementing before that, so it's not clear if it's because the diet was sufficient or I already had a sufficient nutritional status to last me through those 6 months. It's not clear that someone else would have a different experience. There are some vitamins that we can do better than just what our diet can do. The recommended daily allowances are usually set at levels to minimize the amount of disease we have due to nutritional deficiencies. But just doing better than a deficiency doesn't mean that we've gotten to the optimal level. Effective dose, and then there's a minimum optimal dose. If we give our bodies more sometimes, then they can do more, and they can do better. I think vitamin C is one of those areas too, because everyone knows we don't make our own vitamin C. And there are factors related to either a low carb or especially a carnivore diet where we know that glucose competes with vitamin C for the same receptors and can block it out. So if you don't have exogenous carbs in your blood system, then there are more transporters available for smaller amounts of vitamin C. Also, if you're not triggering your immune system with plant toxins, then the glutathione that your body might be producing, thione and vitamin C reduce each other, which you can think of as recycling each other. So you not need as much vitamin C for that reason too, is that your body is recycling the vitamin C that it has when it's not having to fight off plant toxins. And then beyond supplementation, we also have the cost of food. For some people, I certainly don't eat steak very often. I eat a lot of chuck roast, eggs, hamburger meat, a little bit of seafood, and then just whatever meats are on sale. If that's bacon, if that's sausage, I'll try to get less processed versions of sausage with fewer ingredients. But I only eat steak if it's on sale. For a lot of people, they feel that I couldn't eat as well if I wasn't shopping the sales. So I usually end up paying between $3 and $5 per pound of meat. If I were getting steaks all the time, sometimes I see those up to $20 a pound, and there's no way I would want to afford eating the way that I do at that price. I just would feel like that's not a good use of our budget. But for other people, if their budget's even tighter, they got more family members, maybe they're on food stamps, trying to stretch that. You can get a long way with hamburger, especially if you buy it in bulk. But it is a limitation, something we have to factor because some people just won't eat it if they feel like they can't afford it. Let's start to bring it around closer to the oatmeal discussion. There was a debate that I saw between Kinberry and Gil Carvalho from Nutrition Made Simple, where he was interviewing Dr. Berry about a video he'd made saying that most people shouldn't be eating oatmeal. I looked at videos by Eric Berben, and it was interesting not only what they were saying about it, but how they're saying it, what evidence they were using to support their contentions. And so, especially between Dr. Berry on Nutrition Made Simple, Dr. Berry was arguing more based on a lot of his population being metabolically unwell and the underlying physiological impact of having too many carbs in the diet, especially for diabetics, who, if we understand diabetes to be a disease of too much sugar in the diet, and anything you can do to reduce sugar is probably a benefit. And then Dr. Carvalho relying more heavily on randomized controlled trials and this basic nutritional points of view. Considering the scientific hierarchy of evidence, I think we have to consider how these things are communicated in those interviews. There's challenges in the way things are translated from the science down to public awareness. If something starts with the scientist, then science reporters might pick it up, journalists might pick it up. Somewhere in the mix, you get lawyers and politicians who have their own standards of evidence. It goes through public health officials, and it goes through social media, and a lot of times ends up as a meme saying, eat this food, don't eat that food. Like playing telephone. But at each level, we strip out the nuance and the initial qualification of certainty that was there, knowing that in the study, we can only know what the study says. We very rarely can or should extrapolate across to other populations that were not studied. But part of the problem is the misaligned incentives when everything depends on funding. The study depends on funding. Reporters and journalists depend on funding. Their publications depend on funding. Politicians depend on funding. Public health depends on funding. Social media depends on funding. And so we end up with a lot of misaligned incentives at every step of the communication. Usually, if you want to know what was actually said, you have to go back to the original research. And not only that, but you have to go back to their citations as well. So it's not enough to just read the headline of a research paper. You need to read the abstract, see what they actually tested, see what results they're claiming, see if the conclusions are consistent with that, because it's really easy and fairly common for the headline or the conclusion to embellish a little bit on the actual importance of the finding. There's a real strong incentive to make your research sound like it's more important than it may actually be. There may be a statistical significance, but not a clinical significance. Statistical significance means we've determined that within a certain standard of certainty, the results we see are not due to random chance. But that may not mean that even though we see that difference and we say that it's not random, that therefore will make a difference if you change the way you eat based on what you're seeing in that study. So the clinical significance means, is it going to make a difference in the population if they adapt something based on that information? I want to try to bridge the gap here in some of these different approaches. If you're familiar with behavioral economics, we got that field of study because an economist and a psychologist realized one day that they were talking about the same underlying population. People were using completely different assumptions, getting completely different results. Whereas economics was good at creating these formulas that could assume that people had perfect knowledge, acted perfectly rationally, would act in their own best interest, and could think long term. And then the psychology part saying that people sometimes act very irrationally, sometimes act in the interest of others, sometimes act in their own interest. But there are problems that are touched by both fields. And I think nutrition would benefit from the same sort of perspective. I think we have doctors on the one hand that understand human psychology better and the way that people eat in their homes, or out at restaurants or at parties versus the nutrition research that's able to control all those factors. And that's why they say the energy balance model predicts a certain amount of weight loss over time. And one thing that's interesting is that the alternate model is the carbohydrate insulin model. That's the one that says carbohydrates cause insulin responses, insulin response causes fat storage. And so it tries to predict based on your carbohydrate intake instead of your overall energy balance. And when everything's controlled, energy balance explains a lot more than the carbohydrate model. But when we look at metabolism and the underlying physiology and the fact that sugar strips off the glycocalyx, which is a protective barrier on your blood vessels, that's no longer an energy balance issue. And that's better explained by the carbohydrate model, showing that excess carbohydrates can cause metabolic disorder. According to the carbohydrate insulin model, we don't overeat. We're hungry. We get hungry because we overeat. So it turns the energy balance model on its head from saying that we store extra fat when we eat too many calories to saying the opposite. I think Gary Taubes explains it fairly well in his literature, but these two models appear to contradict each other. I think it's because of what Thomas Kuhn said in The Structure of Scientific Revolutions. He talked about incommensurability, which is where two fields or two theories are talking about something similar, but they're actually looking at it from a different way, in a way that appears to make the two theories incompatible. And so I think that's what we're having happen in nutrition, where we're making an observation that to some degree, whatever the factor from eating ultra-processed foods, eating too many refined carbohydrates, eating too much sugar, are contributing factors to excess weight gain, obesity, diabetes, type 3 diabetes, type 4 diabetes, cancers, Alzheimer's. There does seem to be some connection to the amount of sugar we're eating on that. Now, if you put us in a controlled environment and you're making sure that the person is substituting other carbohydrate calories out, then yeah, your equation predicts a certain amount of body fat or a certain amount of weight loss, and then we see that. But that's the classical economic point of view, where we have our formulas and everything else is controlled and we get certain outcomes predictably. But we know that people, free living people eating what they have available to them, are not necessarily going to eat the way that the equations predict. And so I think to get the best of both worlds, until neither hypothesis has been able to rule out the other one in all contexts. Each one can point to certain contexts where their model explains the world better. Another part of the difficulty of separating all that out is we're testing people in a population with all the Western and civilization diseases. So our underlying control group may be baseline unhealthy. I think Peter Attia has said that 90% of the population has at least one factor of metabolic syndrome. I haven't been able to find where that figure comes from, but it sounds right, and it seems consistent with the other data we have. Meaning, if our research is based on low-level, widespread metabolic disorder syndrome, any experiment we get in these controlled trials are going to be biased by that underlying state. So the control group is already biased. And it might just be from that low-level group, or it could be something like the healthy user bias, which I've seen people disparage but never really disprove. That healthy bias is that people who practice one healthy behavior, eating fiber, often practice other confounding behaviors like eating less processed food, drinking less alcohol, smoking less, exercising more, having better air quality, like all the things that healthy people would do. Or that affluent people would do. When we had lots of studies saying that moderate alcohol is okay or even beneficial, one of the things that we're not able to rule out is that people who can afford alcohol probably have slightly better quality of life. And at least their financial situation is better than people who can't afford regular wine, alcohol, which is going to be even more expensive than regular beer. And unless we are able to completely disambiguate those things, we really have to take some of these observational studies with a grain of salt. If we were able to isolate an underlying population didn't have any factors of metabolic syndrome, like some of these hunter-gatherer tribes, we can't run randomized control trials on them versus Westerners and say something more substantial about nutrition. As an interesting side story, 20 years ago, right after I got out of the military, I was getting a substantial part of my annual income from doing clinical trials as a participant. And so I saw some interesting things. I know, for example, we do a lot of studies where we'd have blood draws. We'd get dosed a medication. We get a blood draw every hour and every 4 hours. We do a lot of blood draws in a day. Some people, their blood was not red when it was coming into the vials. It was brown. So they were deemed a healthy participant, but for whatever reason, they were not healthy looking. I know at least one other participant that I saw regularly was living on the street. I guess he was clean of other drugs. A lot of people were donating plasma. I don't know if they were reporting that. I do know a lot of people were going from one study to the next without any washout, just by changing the company that they were participating with. I knew one guy, and I think I felt bad after I did this, but I was just out of the Army, and it was like, guys, they tease each other, right? And we came into the study, and you're not allowed to bring in outside food or drugs, of course. And I realized after the fact, because I'd seen him walking along the highway, that he was probably homeless. And so he just brought everything he had with him. And he had an entire loaf of white bread with him. I don't know if that was going to be his meal when he left or what his plan for it was, or maybe he just didn't have a plan. But they told him, you can't bring that in. He was like, what am I supposed to do with it? And so me thinking I was teasing him, I just said, well, you got to eat it. And so he proceeded to eat the whole loaf of bread right there, white bread. And I felt bad after that because I guess I had assumed he would think that's funny and not actually do it, but he did. And I'm sure that affected the results of his. If you go into a study with a huge insulin spike from eating an entire loaf of white bread, I'm sure that had some effect on the study. I know me personally, whenever I knew the study would be fasted the morning of dosing, I would just go out and eat as much as I could. I would go to a Chinese buffet or something like that and eat as much as I could fit in right before we checked in the night before. And of course, maybe that controls if I do the same thing every time. But then we would get fed, and we would be fed these sandwiches on white bread, and it didn't matter what your body weight was. You got fed the same thing. So me, if I were a 165-pound male, we get fed the same thing as a 110-pound female. And so there's just a limit of all the things that can be controlled for. And so even when we have randomized control trials, it's hard to say if we're going to rule out the placebo effect, we're going to rule out what an actual control is. Even water is not completely inert. Knowing that we were going to have so many blood draws, I would stay extra hydrated the night before, because once you get dosed, you don't get to drink anything besides what you were allocated until they're done drawing your blood. And most people wouldn't do that. So I know they were dehydrated going in. And if you get dosed with an 8-ounce glass of water, that's going to make a difference in the outcome. So anyways, those are some of my thoughts about controlled trials. And I think it's not really fair for scientists or to compare nutrition science to other fields. I think coming as someone who's multidisciplinary and seeing what the research approaches are from different fields, every field has its own research methodology, whether it's qualitative or quantitative. And if a physics scientist wants to make fun of nutrition science and say it's not a real science, I'd invite them to come in and see if they can design better experiments, because it's messy data and it is squishy, but we're doing our best with the the scientific process. We can only do what we can do. So we're trying to make sense out of it. And hopefully we get to places where politics influences the science less than it appears to have in history, in religion. But until then, we just have to do the best with what we have. And until we can rule out either the energy balance model or the carbohydrate insulin model or the other models that are coming up, the lipid energy model, I think the best we can do is take what we can from all of them and approach nutrition in a way that is not contradicted by any of those. So that's generally why I would recommend a low-carb diet for most people. I think most people could do even better on a ketogenic diet and should consider a carnivore or a ketovore diet. I think that checks all the boxes. You don't run afoul of the carbohydrate insulin model. If you've reduced the number of ingredients going into your food, it's much easier to manage your energy balance. And then we see the lipid energy model really take flight and nourish a person when they are fat adapted. So I think we can use the best of both of what we know. And I think if we think about it in terms of behavioral economics, and things are predictably irrational, and that we have to do our N equals 1 ourselves, I think that's really the answer to the question of whether oatmeal is or not. It obviously depends. It depends on what your goals are. It depends on which models you want to follow. It depends on what your underlying health status is. It depends on what toxic exposure you want to incorporate into your life, how much sugar you want to consume. So I understand why a lot of videos will have saying oatmeal is bad or try to debunk someone saying oatmeal is bad. But I think we have to take a step back, understand nutrition within the context of philosophy of science, what we can know, what we can quantify, and what uncertainty we need to be mindful of. Until next time, keep focusing on your metabolic health. Look better, feel better, do better, be better. See you next time.